Hi, this video lesson will bring us through Chapter 6 on further coordinate geometry. Now, previously, you have learned two types of graphs, which are straight line graphs and quadratic graphs, and their general equations are as such. In Chapter 6, you will learn three more graphs, and they are equation of a circle, graphs of y squared equals to kx, and graphs of power functions. Now, in this video lesson, we are only going to focus on equation of a circle. Equation of a circle has two different forms, namely the standard form and the general form. Now, before I introduce you to the two forms of the equation of a circle, you need to know the important features of a circle. Over here, you see a diagram of a circle on a coordinate plane. Over here, you see point C, which is the center of circle. Here, you see length R, which is actually the radius of the circle. Firstly, this is the standard form of the equation of a circle. In all standard forms, the x and y here are fixed. What changes would be the values of a, b, and r. So, what do the values of a, b, and r determine by? Now, firstly, the values of a and b are determined by center. Now, a is actually the x-coordinate of the center, and b is the y-coordinate of the center. Next, r here is actually determined by the radius of the circle. With this, it is actually very easy for us to find the center and radius of the circle given its standard form of the equation. For example, let us take a look at this equation. Now, if I were to find the center of the circle, this is what I would do. To get the x-coordinate of the center, I would focus on this function, x minus 1. What I need to do is I can actually mentally let x minus 1 be equals to 0 and then solve for x, which is equals to 1. Now, x equals to 1 is actually the x-coordinate of the center. Next, to find the y-coordinate of the center, I will now focus on y plus 3. I'm going to let y plus 3 be equals to 0 and solve y to be equals to minus 3. Now, y equals to minus 3 will then be the y-coordinate of my center. So, this is actually the full coordinates of the center. Next, if I need to find the radius, I need to use the value 16. Now, based on the standard form above, the right-hand side of the equation should be in the form of r squared. But here, we do not have a squared. But 16 is actually 4 squared. Hence, my radius can be determined by taking the square root of 16, which is equals to 4 units. Let us now look at work example 1. In this example, we are to write down the coordinates of the center and the radius of each of the following circles A, B, C. So let us now do the solution for A. Now, all mental calculation I will carry it out within this box here. So, to find the center of circle A, firstly, I will need to calculate the x-coordinate of the center. To do that, I will let x here be equals to 0. And there we have it. X equals to 0 would be the x-coordinate of the center. Next, to get the y-coordinate, I will focus on y here and let it be 0. Again, I have the solution y equals to 0 as the y-coordinate of the center. Next, to get the radius, I will focus on the constant that is on the right-hand side of the equation, in this case, which is 16. So, to get the radius, now this I need to show the working. For the radius, I need to take the square root of 16, which will be equals to 4 units. Hence, I have answered for circle A. Next, for circle B, to get the x-coordinate of the center, I need to let x plus 1 here be equals to 0. Now, please do not take y minus 1 if you are trying to find the x-coordinate. X-coordinate means x plus 1 here. So, x plus 1 equals to 0, x will be equals to minus 1. So, which means that minus 1 is the x-coordinate of the center of the circle. Next, to get the y-coordinate, we will now let y minus 1 be equals to 0. Here, y minus 1. Y will then be equals to 1. Hence, 1 will be the y-coordinate of the center. Next, to get the radius of this circle, we will let square root 36. Okay? And we square root it. The answer will be 6 units. Next, we move on to part C. Now, if you look at the equation in part C, it is a little bit different from parts A and B. If you notice, the constant term is actually on the left side of the equation, unlike parts A and B, which are on the right. Hence, to make use of our previous concept that we have learned, we need to move the constant term to the right side of the equation. Hence, it will now look like this. Only when the equation is as such, then you can do the calculation. If I need to calculate the center of the circle, firstly, for the x-coordinate, I have to let x plus 2 be equals to 0. Hence, x is equals to minus 2. And this is the x-coordinate of my center. Next, for the y-coordinate, I only have y here, so I let y be equals to 0. And therefore, 0 is the y-coordinates of my center. Next, for the radius, I will have to take the square root of the constant term, which is on the right side of the equation, which happens to be 64. And the answer will be 8 units. So that is the end of work example 1. Work example 2. Now, sometimes the question doesn't start off by giving you the equation of the circle. Instead, what it gives you is the center and the radius. And then you are asked to find the equation of the circle in standard form. Now, this is the equation in standard form. So from here, what we need to do is to find the values of A, B, and R given in the question. Now, we know that A is actually the x-coordinate of the center, which is minus 1. B is 2. And R is the radius. So what we do next is to just insert these three values into the standard form. Now, of course, you can't leave the final answer like this. You have to actually simplify the whole equation. And finally, it will look like this. So that is the end of work example 2. Work example 3. Find the equation of the circle with diameter AB where the coordinates of A and B are given as 1, 4 and 3, minus 2 respectively. Now, if we need to find the equation of a circle, we need to remember that we need two pieces of information that are the center and the radius. So, let's think. Using the two coordinates given to us here, can we find the center and radius of the circle? Now, if I were to roughly sketch the graph, it will look like this, where C is the center of the circle. Now, C should be the midpoint of A and B. Hence, to find the center of the circle, we can just use the midpoint formula and we get the coordinates of C as 2, 1, which is the center. Next, for the radius, we can either find the length of AC or the length of CD since we now have point C. So in this case, I found the length of AC, which is square root 10. So with these two pieces of information, I can easily insert into the standard form, which is this, and finally simplify it to this, which is the final answer. Next, we will be moving on to the general form of the equation of a circle. Recall the standard form as such. Now, basically, general form of a circle equation is the expanded version of its standard form. For example, if you have this equation in its standard form, the general form would be this after you have expanded the standard form. Now, one other difference is that the constant term for the standard form is on the right side of the equation, whereas for the general form, the final constant term will appear on the left side of the equation. For all general forms, the right-hand side of the equation will be equals to 0. So, next, how would you find the center and radius of a circle given its general form? Now, this is the general form of a circle equation. Take note that for x squared and y squared, their coefficients would be 1 and only 1. Next, the coefficient of x term is a, coefficient of y term is b, and the constant term is known as c. Now, if you need to find the center of the circle from the general form, this is what you do. For the x coordinate, we will take the coefficient of x and divide it by -2. For the y coordinate, we will take the coefficient of y and divide it by -2. Hence, this is what we will get. Then, to calculate its radius, we will take the square root of the x coordinate of a, the square of the x coordinate of a, plus the square of the y coordinate of the center, and then minus c, which is the constant term from the general form. Now, it would be good if you can memorize these two equations, since they will not be provided in the formula sheet. We have now come to the last example for this video lesson. Work example 4. Find the center and the radius of the following circle. Now, if you look at the equation of the circle, it actually looks very similar to the general form. However, notice that the coefficients of x squared and y squared are not 1. Hence, you need to ensure that they become 1. So to do that, we need to rewrite the equation by dividing throughout by 2. If you do that, notice that now the coefficients of x squared and y squared will now be 1. Next, to find the center, what we need to do is to apply the formulae on the previous slide. So, to get the x coordinate of the center, what we do is we take the coefficient of x, which is -2, and divide it by -2. For the y coordinate of the center, we have to let the coefficient of the y term and then be divided by -2. And finally, the answer will be 1, -1/4. Then, we would need the coordinates of the center to find our radius. According to the formula from the previous slide, to find the radius, we need to square root the square of the x coordinate of the center plus the square of the y coordinate of the center minus the constant term from the general form, which is -1. Here, this will simplify to square root 33 over 16. Or you can simplify it further to square root 33 over 4 units. Now, we have come to the end of the video lesson. After all the work examples, do try the following questions from exercise 6A of your textbook. All the best!